Having looked at the general anatomy of the urinary system, we're going to jump right in now to the nephron and take a look at some of the basic structures there. So look in the bottom right, there's a nephron. Okay, that is the working machine of your kidney. You got about 1 million of them per kidney. See where there's that red ball? That's called the corpuscle, the renal corpuscle. Um, Glomerular capsule is composed of, and the glomerulus. So take a look on the slide. I jumped ahead and didn't have you follow me along. So look on the big slide on the left. See how that entire picture is a renal corpuscle with blood vessels going in and out. But the corpuscle is composed of two parts: the capsule that goes around, and the actual glomerulus itself, which is a bunch of capillaries that do the filtration of the blood. So the glomerulus is like the working machine of the kidney. The capsule just protects it, it just houses it, contains it, all right? So once again, the whole thing is the corpuscle. Corpuscle composed of two parts: the capsule, which is the container, and the glomerulus, which is the machine. Now, the capsule itself has two layers: a parietal layer. We've seen this so many times, all right? Then a capsular space, all right? And then on the capillaries themselves, there is a layer of cells called podocytes, and those form the filtration membrane. So they also then they function as the visceral layer of the glomerular capsule. Right? Go back and listen to that again if you need to. It's not that difficult. It's just that you've got a few layers there of terms, but they all are perfectly logical. So corpuscle is glomerulus plus capsule. Glomerular filtrate collects in the capsular space and flows into the renal tubule. So the blood comes in. Notice how we have the afferent and the efferent arteriole. Look at how big around the afferent is, and look at how narrow the efferent is. That means a lot of blood is coming in, but the same volume can't go out. So what does that do? Well, that creates incredibly high pressure inside the renal corpuscle, and that high pressure is what forces the stuff out of the blood, basically everything. And it forces it out into that capsular space, and then it flows into the renal tubule. So see the big picture on the left, see coming out of the corpuscle on the right is the proximal convoluted tubule. Proximal because it's nearest to the corpuscle, and convoluted because it's all twisty. Look again on the far right at the picture of the overall glomerulus. See the yellow parts are the tubes. See how they get all twisty? And that's not a very good picture. The upper right hand shows it a little bit better, but it's hard to see. We're going to see a close-up of that coming up. The visceral layer is the podocytes. Those are wrapped around the capillaries. So let's look at the tubule, the renal or uriniferous tubule. I normally just say renal, I think, but you can use either one. So the proximal convoluted tubule. Notice coming right out of the corpuscle, the very first part of the tubule is all twisted around. It's convoluted. It's the longest and the most coiled. That's where 65% of the filtrate is reabsorbed. So once again, I'm going to keep repeating this. I'm sorry you're getting bored with it, but I just got to make sure it gets through. Once again, the kidney basically forces everything out except red blood cells and proteins. Those are too big. But into the capsular space, all the stuff gets bumped out. The stuff that we want to get rid of, yeah, great, urea, creatinine, but also stuff that we want: amino acids, glucose, vitamins, minerals. So we have to bring those back into the blood. That mostly happens in the PCT. Roughly 2/3 of all absorption, as we call it, takes place in the PCT. Reabsorption is controlled by concentration gradients and active transport. So once again, there are active pumps pumping it, and we're also taking advantage of concentration gradients to do that, facilitated diffusion. You got a huge concentration gradient for sodium. Why not let things ride with sodium across the gradient, okay? That's the way reabsorption is controlled. A lot of gradients, a lot of transporters. Then, from there, from the PCT, notice how the tube dips down, and it makes a loop and then it comes back up. That whole thing is the nephron loop. It has a descending portion, then there's a U at the bottom, and then there's the ascending portion, all right? And when it ascends, it comes back up close to the corpuscle again. See how it comes up and does kind of like a drive-by? So within the loop itself, there are thick segments. Those are mostly for the active transport of salts. And by salts here, we mean all that. Sodium, potassium, calcium, magnesium, those are all salts. The thin segment is where we control water. So notice how clever this is. Go back to day one. Remember when we talked about fluids and solutes and osmotic pressure and so on? So what's going to happen here is the thick segments are going to be able to move both ions and water across, mostly the ions, but when the ions move, they'll pull water with them, whereas the thin segment is mostly just for water alone. That is what allows the nephron to control osmotic pressure, because it can move both water and solids one place and only water in another place. It can control their regular concentrations. That's an important point. I'll keep trying to come back to that. Then the distal convoluted tubule, the DCT, at the top of the ascending limb, that's where most reabsorption secretion here is controlled by hormones. So there are a bunch of hormones we're going to see with the kidney. This will be a good preview of endocrine. But things like ADH, antidiuretic hormone, this is also where aldosterone works and so on. So we've got a bunch of hormones that are going to have an effect here on reabsorption secretion. And they're going to have that effect right here in the DCT, okay? Looking again at the tubule, there's a collecting duct. So notice how on the picture on the right, you can see a couple of corpuscles there. The big red balls, those are the corpuscles. Then notice in between them, there's a big giant tube called a collecting duct. This is where urine collects. At this point, we're done moving stuff in and out for the most part. It's just, here we're going to go ahead and say it's urine. So urine is going to flow down that collecting duct. Notice how bunches of, see how that big yellow tube there in the picture on the right looks like it's got branches that were chopped off? Those are all DCTs from other nephrons coming in. So one collecting duct pulls in urine or drains urine from a bunch of different DCTs, a bunch of different nephrons through their DCTs. It concentrates the urine here. So there is some movement of water, all right? Flow of glomerular filtrate. So let's talk about let's from the time that the kidney makes the urine, all right? Let's follow and see how it goes. I would expect you to do this just like the path of blood. So we're going to start in the glomerular capsule. That's where we filtered it all out. Then it goes into the PCT, through the nephron loop, descending, ascending, into the DCT, then into the collecting duct. Then at the bottom, the collecting duct, once all the DCTs have come in, from that point on we call it the papillary duct, because it leads down to the renal papilla. Then that drains into the minor calyx, that drains into the major calyx, that drains into the renal pelvis, that drains into the ureter, which then collects in the urinary bladder and is eliminated through the urethra. And where does it go from there? I hope you all know the answer to that. Where does it go after it leaves the urethra? It goes onto the ground, because that's where you should pee. There's no reason wasting the water in the toilet to flush urine. You should just pee in your own yard. I do that all the time. When I have to pee, I go out in my front yard, I pee in my front yard. Cars drive by, I wave. You know, it's my fucking front yard. I can do whatever I want. So, and yeah, 4th Avenue, 2 in the morning. Yeah, I bet Mom's proud. So, nephrons. True proportions of nephron loops to convoluted tubules shown. So on the left side, you see those are really basically pictures. That shows the true in your kidney relative lengths of the size of the corpuscle and the length of the tubes. Sometimes the books show it kind of condensed. That's a more realistic picture. Cortical nephrons versus juxtamedullary nephrons. So some nephrons are way up high in the cortex. We call those cortical nephrons. Some are down, if you look at the picture on the left, you can see that dividing line there between cortex and medulla. Notice there's a nephron that's right down near the dividing line. That's called juxtamedullary nephron. Juxta means next to, medullary, the medulla, so it's next to the medulla. So do you get it? See, it's really easy. Cortical nephrons are way up high in the cortex. Juxtamedullary are next to the medulla, so it's easy to spot them, all right? Cortical nephrons are 85% of all your nephrons. Short nephron loops, efferent arterioles, peritubulars, that's right, because they're way up high. Whereas juxtamedullary, only 15, but they have very long nephron loops. Look at the relative size there. See, it has a really, really long nephron loop. And that helps maintain salt gradients and helps conserve water. That's one of the ways the kidneys is controlling your water balance. Let's talk about how blood moves through the kidney. There are lots of little blood vessels, but they're all named in a way that makes them easy to remember. Really are. So the renal artery comes in, then it branches into segmental arteries. There are a couple of segments of the kidney, so there are a couple of segmental branches. Then interlobars. Those run up the renal columns. They're interlobar, in between the lobes. Remember the slice of pumpkin pie was a lobe of the kidney? So in between two slices of pie is the renal column. That's where you find the interlobar arteries, again, because they're between the lobes. They curve over the top of the pyramids, and once they curve, we now call them arcuate arteries. It's the same damn tube. Once again, it's like you're driving on, Grant, and suddenly it says you're on Kolb, and you didn't make any turns. You're going like, WTF, what happened here? Now, it's the same damn street. They just changed the name at some point, okay? Interlobar is coming up the columns. Once it curves over the renal pyramid, we call them arcuate. Then they go up through the cortex. So now we have the cortical radiate because they radiate into the cortex. There's an old other name for them, interlobular. I recommend you don't use that because it sounds too much like interlobar. So I'm not going to even say it again. You've got interlobars, then arcuates, then cortical radiates. Coming in, we have the afferent arterioles, all right, coming into each corpuscle, so down on the lower left, coming in, we have the afferent arteriole. Then there's the glomerulus, the big giant wad of capillaries where the blood comes through at incredibly high pressure, forces everything out into the capsular space. Then the efferent arterioles take the blood back out again. Peritubular capillaries, then, if you look in the bottom right, those are going to be capillaries that wind all around the nephron. On juxtamedullary nephrons, they form straight lines down the nephron loops, and there they're called vasa recta, straight vessels. Then the cortical radiate veins. So now let's bring the blood back. As the blood comes back, it's going to come back through first the cortical radiate veins, then into the arcuate veins, then into the interlobars, and then finally into the renal vein. And that's the blood flow. I could ask you about that just like I asked the path of blood. It's not hard. Look at the diagram on the right and just practice on your own. It makes total sense. Blood comes in, blood goes out. It's easy. Just watch where it goes. There you go. A cortical nephron, a juxtamedullary. Look at how both have peritubular capillaries, okay? See up by the corpuscle? See how both of them have peritubulars? The cortical also has peritubulars down on the nephron loop. But the juxtamedullary down on the nephron loop, instead of having all those cross branches, they're just big straight tubes called vasa recta, literally the straight tube. So there you go, nice summary slide, shows all those renal pathways for blood. All right, good graphic there. Let's talk about how we're going to make urine. This is a preview. It'll be the next PowerPoint where we talk about the actual formation. But let's look at the basic outline here first and get that clear in our head. Then we can go ahead and dive into the separate steps. So 4 basic tasks: filtration, reabsorption, secretion, concentration. And the words, once you get used to them, tell you exactly what they are. Those are good words. Those are the right words to use. You'll see. First, the nephron filters small solutes out of the blood into the filtrate, which is similar to plasma. All right? This is called filtration. So in the capsular space, we now have a plasma-like fluid. The big difference is, of course, that there are no proteins. Red blood cells and proteins are too big to filter out. If you are filtering out proteins, that's often a sign of kidney trouble, all right? So if you get a urinalysis done and you have something like hyperproteinuria, too much protein in the urine. Hyperalbuminuria, too much albumin in the in the urine. That's a sign that your kidneys are not working correctly and they're letting proteins out. That shouldn't happen. Next, we just dumped everything into the filtrate, right? In the capsular space. What we need now is we're going like, whoa, there's a bunch of glucose and amino acids and other good stuff in there. We better pull those back into the blood. That's reabsorption, all right? So a lot of that is going to be active transport and also using concentration gradients. Get the good stuff back into the blood, okay? Now then, we get to the point where after we've done all of this, we should have things about right. But in fact, now the kidney looks and says, there are still a few things in the blood that we should probably get rid of. And that is secretion. Additional wastes are removed from the blood and put into the filtrate. That's the last final adjustment, okay? Finally, water is reabsorbed and returned to the blood, which concentrates the urine. That's concentration. And a lot of that can happen in the collecting duct, okay? So notice that. Get those straight. Make a little note of that on a little separate card or something. Note the 4 things the kidney does. First filtration, then reabsorption. That wasn't coronavirus. First filtration, then reabsorption, then secretion, then concentration. First, dump everything out. Then put the good stuff back in. Then take a few more things that were still in there and get rid of them. And then concentrate the urine. I say it's kind of like when you clean your garage. So first, you got a garage that looks like the upper left. It's like, oh God, this is going to take all weekend. So first, easiest thing to do sometimes, just put all that crap on the driveway, all right? That would be filtration. Take everything out, all right? Then, once it's all on the driveway, you go, all right, what do we actually want to keep? So you start taking the good stuff and put it back in. Notice it's not so much you decide what to get rid of. A much more efficient way to do it is decide what are we going to keep and put that stuff back in. And then at that point, everything left on the driveway should be stuff we get rid of, all right? And that's good. We're not going to change our mind about that. We're going to get rid of that stuff. But then also, when we look in the garage, we go, babe, do we really need that croquet set from your Aunt Rosemary? We've had that for like 7 years now. Could we? But what if Aunt Rosemary ever comes to visit? Babe, I don't think she's going to. She's in a wheelchair. She's 87. I don't. And then you end up getting rid of it, but she doesn't talk to you for like a week, whatever. And then take all that bad stuff, that is a waste product, and put it in the garbage cans. Okay, yeah, get rid of it. Feels good. Okay. And yeah, that's the concentration. Putting it in the garbage cans. All the stuff we're going to get rid of. In the dumpster. Drive it to the dump. Take it to the transfer station. Right? Borrow somebody's pickup truck. Yeah, I got a pickup truck. Hey, Tom, are you doing anything this weekend? You got that truck? Oh, yeah, fine. Torweep. This is one of those crazy times at Torweep. As the sun sets over by Mount Trumbull, oftentimes there are clouds during the summer, and so it forms these slits, and the sun shines through like a flashlight. So especially lights up the sky and the lower parts as well. So you get these just surreal sunsets where the sky is almost bright like the sun because it's reflecting so much light. That's the white that you see down the river. Those are the rapids, and the area next to that going up, that dark black area, that's the lava flow. That's what you hike down. That's what I hiked down and got stranded at the bottom. I got lost. After I hiked up and down the river for a while, I went to go back up and couldn't find my way. That's when I had to flag down the raft and ultimately pay the helicopter pilot $300 to fly me back to my truck. But it was fun. It was worth it. It was an adventure. Okay, I'll see you in the next one.